Hi, I'm from SIPS. Do you want to check whether you can share the slides so that everything is good on your end?
Oh, I'll give it a go. Should be able to see that now.
Now it's oh yeah, so this is better, yeah. We don't see your notes. Yeah, this work.
Great. Okay.
What about the other speakers? I'm not sure if all of them are present here now. The moderator will come in a second. So I'm just
great.
here to help her.
You should be seeing mine.
It's yeah, I can see it.
Okay, and you can hear me, right?
Yeah, I can hear you.
Wonderful, thank you. I'm just going to stop sharing.
Mm-hmm.
Oops, not what I wanted to do. Yeah, here. Should be okay.
I don't see the third speaker, Morillo. It's joining. Okay, just Daniel should check their slides. The rest already worked. Hi.
Good morning.
Okay, I will write a message privately. We can start, I think, right?
No, first, Daniel, can you share your slides with us so we make sure that everything works, and then we can start?
So I start in the first place then?
No, just to check that you can share your slides with us.
Okay.
I think you're the last one.
Yeah, I suppose so. But
Yeah.
here would be my presentation.
Yeah, great. We can see it. So Anna, now it's your turn.
Okay.
Perfect. Hello, everyone. Welcome to Lightning Talks 4 through 6. Today, the speakers will be Cooper Smout, Dunya Lakjum, Daniel Morillo, and Dermot Lynott. I'm really hopeful I pronounced the names correctly. I'm sorry if I didn't. I will be the moderator. I should also mention that we have a very strict time limit, so I would ask everyone to be mindful of the time. Each speaker has 10 minutes in total. This includes both the presentations and the Q&A. Before we start, I'd like to ask if everyone is okay with the fact that we're recording this session. If someone is not, please let us know. Yeah, and I think we can get started with our first talk by Cooper Smout.
Great, thank you. So hopefully you can see my slides. Yes?
Yeah, perfect.
Hi everyone, thanks for having me. So yeah, my name is Cooper. I'm representing the Open Heart and Mind community, and I'll be introducing a novel mechanism called Metavaluation that we have developed to enable any community to fairly value a diverse set of contributions. And so the motivation behind this project is basically, it's based on the premise that our institutions are fundamentally broken. So most of them have gravitated towards profit-oriented models that are not really truly representing the values of the research community or good scientific practice. And I align with thinkers like Buckminster Fuller, who would say that you never change things by fighting the existing reality. You change them by building a new model that makes the existing model obsolete. And so that is our goal at Open Heart and Mind, to create an open scientific system that can quantify the collective value of literally any contribution with respect to the community's values and goals. Because if we can figure out some kind of a percentage that each contributor has produced to the collective mission, then we can directly reward them for that value and then incentivize people to keep on contributing value to the community. Now, there's a problem that's not often addressed in models, and that is that evaluations themselves are valuable contributions to this process, because we need to figure out what things are worth. But this then creates a problem, because if we're going to evaluate evaluations, then somebody needs to evaluate the evaluations of the evaluations, and so on. It's totals all the way down. And so what I'm going to present is a model that closes this feedback loop while being based on good scientific practice, really flexible to enable the evaluation of literally any contribution, and then also inclusive so that everyone in the community can participate in this process. And so it's based on pairwise comparisons we just give someone 2 contributions and ask them to tell us which is more valuable on some dimension of interest. And the key thing that we do is that we zoom out and we include these valuations in the valuation process. So this then gives rise to meta-valuation, hence the name, where we're valuing valuations themselves. And so in this case, we're now asking somebody to compare some regular contribution, like this piece of code, against some number of these pairwise valuations, in this case, 100. And through collecting this data set, if we assume that each one of these reviews that people do is worth 1 standard unit of value to the community, we can use that to basically peg the entire system and calculate a relative valuation for every single contribution that goes through it. And so I'll show you how we did that using a very relevant prototype, which was an open science conference called AMOS. After the conference, we invited people to nominate diverse contributions. People nominated talks, discussion groups, money that people paid, and so on. And we also invited people to nominate some dimensions that we would measure these contributions on. And so the experimental paradigm is basically a randomized controlled trial design where we can compare each contribution to each other contribution twice, forwards A versus B, and then B versus B versus A. And so you can see down the bottom here, we're just asking someone to compare this talk versus this hackathon on each of the 6 dimensions. And they just choose A or B in each case. Now, the tricky part is where we embed these valuations themselves. So we then put in these representative samples, so 100 and 400 pairwise comparisons. And now we repeat the same process, but now somebody's comparing this lightning talk versus 100 of these valuations. And what this gives us is a data set that we can then use to estimate the value of every single contribution. So what I'm showing you here in the blue dots is the number of votes that these review contributions received. And then we can fit a function, which is this blue line, and use that to estimate a score for every single other contribution. So those are the black dots. And because we can do this across multiple dimensions, what this gives us is a multi-dimensional representation of the value of all the different contributions. And from there, we can do all kinds of interesting things. So it's basically a matter of filtering the data in whatever way we want to use it. And so I'm going to show you some prototypes of the ways that we can use this kind of data for community recognition and reward. So here, what I'm showing you here is the gratitude across all contributions, showing basically stacking the gratitude for each person and showing that some people contributed far more than their fair share and other people received more than they gave. And what this allows then is the recognition and reward. Say, for example, if there's free tickets available to the next conference or if there's money to be distributed, we could automatically reward these people based on the collective measure of the value that they've provided to the community. We can also look at reputation profiles. So if we assume the idea that reputation equals value over time, we can measure the value that people have provided in different categories, and then we can start to defer to them if there's particular questions that we need expert opinions on. We can also look at reputation profiles. So in the bottom right, I'm showing that the different categories that one person has contributed. And of course, the question is always, what's stopping people from cheating this system? Well, you never can stop people from trying to cheat a system. That's inevitable. But by making all of the review data publicly available, or at least available to the community, we can develop measures to check which people are actually doing this task reliably and which people are trying to cheat the system. And so here I'm showing just a proof of concept where we looked at the test-retest reliability within a particular reviewer, showing that some people, say this testing 1, 2, 3 person, wasn't very reliable, whereas other people were much more reliable with their reviews. And so this is the first step towards showing that we can basically recognize and reward those people that are maintaining the integrity of the system. And the idea is that this is just the beginning. This is like the beginning of an ongoing meta research paradigm within the community. So I'm showing a proof of concept here where we measured the value of particular contributions versus the value of the money that went into making them happen. And so you can see in some cases, there's a surplus of value created. In other cases, there's a deficit. And this might be suggesting either that it wasn't a very good financial decision to put that thing on, or maybe we're just missing some part of the story and we need to improve our valuation process next time. And so the idea is that this is an ongoing iterative process where each community can improve their processes over time. And in doing so, they're improving the valuation process, which then incentivizes people to provide more value to the community. And so in practice, we've actually been doing this over the last couple of years. We've run 5 main prototypes now, and we're planning to do another one at SIPS tomorrow. And we've looked at this same mechanism across festivals, conferences, and decentralized projects around the world. showing that we can value very, very different types of contributions. And we can also iterate this system as we go, improving and refining the process along the way. And what it creates is not just a more efficient way for communities to coordinate within their own community, but also across different community bounds. Because if any two communities are adopting the same dimension, or they agree that their dimensions are comparable, then they could start to exchange value across the boundaries of their community using these common dimensions. And what I believe this can create is a much more efficient recognition and attribution system than what we have with citations, because we've already proven the concept through these prototypes that we can value the prototypes themselves, so that when a new community comes along and wants to adopt that existing system, effectively the gratitude is embedded into the system for the people who have created it from the outset. And so it creates a kind of flexible, much more transparent, much more collective and fair valuation process for contributions over time. So with that, I want to thank all of our amazing contributors across all of the different prototypes that we've run. Especially want to thank our development team who are hard at work building an open source app right now. And we're expecting that to be released next month. And in celebration, we've just kicked off this monthly cycle where every month this year, we're going to be running a new experiment where we're basically building this on community and process from the ground up. And at the end, it's going to culminate in the running of a fully decentralized festival in Australia. But the idea is that all of this is fully open, accessible, and available to the entire world. So other communities can adopt this community governance toolkit and use it to run their own festivals or conferences or whatever kind of gatherings they want to in the future. And so that it's an open invitation to get involved and play along. You can follow our newsletter, you can join our discussion group on Telegram, or you can join one of these monthly online meetings with the link on the right. And yeah, and if you're around tomorrow, then we'll be hosting a hackathon to value contributions at SIPS itself. Thanks, everyone.
Thank you very much. We have just under 1 minute for questions, so maybe one very short question.
Felix. Felix, what's your question?
Hello, just a short question. So is it a forced choice, A versus B, or could you add a third option, I cannot decide? It's on the same level?
Yes, that's actually been a very requested feature. At this stage, it's forced choice because we want to collect the data, and actually, you know, the evidence shows that you can elicit subconscious biases by forcing the choice. So it's kind of intentional at this point, but potentially in the future, that's a feature we could add. Thanks for the question. All
right, thank you very much. Thank you very much for the talk. And our next talk is by Dermot, Lynott, and Daniel Morillo.
Yes, can you hear me?
Yes, thank you.
Okay, great. Can you hear the screen? Can you see the screen?
We can see and we can hear, yeah.
Okay, great. Thank you. So my name is Daniel Morillo. I work at Maynooth University and I'm a researcher on the project, the TROPIC project, along with Dermot, Lynott. And today I'll be presenting TROPIC, which is a training program in open research that was first developed in the Irish context to help researchers move from knowing about open research to actually implementing it in their own work. So, as we all know, open research has gained huge momentum over the past decade, and it's widely promoted as a solution to many of the issues that undermine trust in science and research in general, from low reproducibility to lack of transparency. And today there is definitely more awareness. However, researchers now know more about practices like, for example, pre-registration, data sharing, and open access than ever before. But despite this, adoption is still lagging. And if you look at this spider plot, the blue lines show high levels of awareness for most practices, but the red lines show actual adoption, and it's consistently lower across the board. So this means that being aware of a practice doesn't mean that researchers are actually using open research practices. So what is holding people back? Often, and in our experience, this comes down to three main elements. So first, they don't necessarily know, so they have knowledge about open research, but they don't necessarily have the practical skills to use the tools. Or they might be unsure if open research is applicable to their discipline or methods. And finally, even if they want to try and adopt them, they don't know how to fit it into their own workflow. So this is why we have designed a solution focused on hands-on portfolio-based training. It's practical and adaptable across disciplines. Participants build real skills, and as they go, they create tangible outputs like pre-registration plans or data management plans for their own research. The portfolio gives them proof of engagement, evidence of their skills, and example of how they have adapted open research to their own workflow. This training program is built around 6 modules, including building a research profile with an ORCID ID and an OSF account, information about questionable research practices and open research practices as a solution, research integrity and how open research can be applied across disciplines, data management planning, pre-registration, and finally finding the right publishing and licensing choices for their own work. And all materials are hosted on the TROPIC website. It is designed to be part course and part a resource hub with guides, templates, and case studies that participants can return to at any point. And if you scan this QR code, you would be redirected to the TROPIC website. So now let's see how the training was delivered during our sessions. On day 1, we focused on foundations of open research. Participants explored questionable research practices, and they mapped where they could arise across the research lifecycle into their own research process. And we then played a fraud detection game using real retracted papers from Retraction Watch and examples of manipulation in papers such as tortured phrases, fake references, or manipulated images. We also introduced OSF and ORCID and made sure that everyone had set up an account. On day 2, we focused on data. So participants filled in a Horizon 2020 data management plan for their own research project, and they applied FAIR principle and were engaged in thinking about data from the very start of the project. And finally, the third day, on the third day, we tackled producibility, and we introduced pre-registration, and participants drafted plans using either as predicted or OSF templates, depending on their methods. And to evaluate the impact of the session, we ran pre and post training surveys on confidence using open research practices. And in the visual here, you can see that lighter colors represent lower levels of confidence, and darker colors represent higher confidence. And what we can see is that by the end of the training, participants reported significantly higher confidence, especially around data management plan and open data, pre-registration, and the overall open research process. And this shift showed us that practical structured training helped them move from passive awareness to active implementation. And to conclude, one of the biggest takeaways from running this program is that awareness isn't enough. Researchers need practical, disciplined, flexible training to build confidence and actually start using open research practices. The portfolio-based format helped participants move from knowledge to action and gave them concrete output to prove their ability to do so. And to scale this impact, we now run Train the Trainer events, helping others deliver this program in their own institutions. And all of our resources, slides, templates, activities are fully open and available on OSF, ready to adapt to your context. So whether you're a researcher or a trainer, you can use this framework to help your community move from awareness to adoption. Thank you very much.
Thank you. We now have 2 minutes for questions. We have a question in the chat.
So who are the type of people who took part in the training? Yeah, good question. So basically we had a breakdown of people who took part, and we had people from psychology, usually they are always involved, but also computer science and engineering, and humanities and social sciences. And in terms of methods, we had a majority of people using mixed methods, and a minority of people using only qualitative methods, and the rest were using quantitative methods. But we had all profiles, meaning that we were in a position to see how this training program could adapt to people from all backgrounds.
Okay, if there are no further questions, I think we can move on to the last talk. Thank you very much.
Thank you.
And our last talk is by Daniel Morillo.
Okay, let's see if I will share my screen. There it is.
Perfect.
Very well. Okay, thank you so much for joining me for the invitation. So my name is Daniel Morillo, as Ana said. I'm assistant professor at the State University for Remote Education in Spain. And the title of this lightning talk is Radical Transparency, a Leap Forward in Open Research Practices, which is my proposal. And let's see if I can convince you that this is the case. So I would like to start this talk speaking about the current transparency standards in scientific research, which, to my understanding, basically comprise pre-registrations and register reports. With a pre-registration, what we do is we publish our intended research design and rationale beforehand, and then conduct our research according to them. Register reports are like a pre-registration of sorts, we could say, but they are published in journals after peer review. We can also publish partial outcomes, such as our hypothesis, design, data analysis, our results, as different products. For example, we have Octopus, or we have nowadays the Life Cycle Journal. The idea behind transparency is to publish partial outcomes of the research process as early and as detailed as possible, so that they can be assessed in depth by the scientific community, and we can also commit to them ahead of time. So here is what a register report workflow looks like, where we publish first the design of our study, and later we conduct our research. This is a great way of showing transparency in our research work, but there are two things missing, in my opinion. First is what happens until we arrive at our published study design or at our results. What happens in between? Surely there have been many changes and versions along the way. There has been a lot of reasoning, a lot of trial and error, setbacks and recoveries, pilot studies, for example. All of that is and should be regarded as scientific knowledge in itself, right? Wouldn't you agree with that? So if this is our register report, all of these partial versions, which provide the evidence for that research process, are usually lost. Also, a bigger problem arises when unexpected things happen and our paper does not match our published report. For example, some features of the empirical data may require intermediate processing that was impossible to foresee during our study design. And we all know that these things happen more often than not, unfortunately. So with this model, we are only making public our research outcomes intentionally. That may lead us to overlook important changes that explain the evolution of our research projects. Of course, there are other problems as well. For example, we know that pre-registration and register reports do not adapt to every possible research design. So if we are conducting exploratory research, how do we demonstrate transparency, right? There should be a way for that. So the transparency model we advocate for is what we call radical transparency. What we mean by this is that all the evolution of this research project through time what we would refer to as a temporal footprint of the project, be made public eventually, that the whole process of developing all research outcomes can be openly available in a similar way as how collaborative open source software is developed. But of course, we want to make this without delegating the responsibility on ourselves, the researchers, because that would increase the burden on one side, and that would make the process error prone on the other. So we need the proper technology for that. But I argue that this technology already exists, and it's called version control. With it, we can create iterations of our research products without requiring extra effort from the user in a Google Docs-like style, we could say. But what we need are the right tools, ones that implement this technology, but serve the purpose and the needs of researchers. Hopefully, those tools could help us reduce the burden of other open science practices at the same time, making it as easy as possible to publish our partial or our final results, whether they are our papers or partial products like FAIR data, syntax, protocols, registrations, etc. That way, I think that radical transparency could serve our needs, and it could help us understand and diagnose better the validity of scientific conclusions, prevent fraud and unintended bias, and improve our research practices. So if you are interested in helping develop further these ideas, I encourage you to please join the discussions at the in-person SIPS at 11 a.m. on Friday the 17th. So thank you so much.
Thank you very much. We have 4 minutes for questions.
I'm sorry, I'm not sure if there are. Okay.
For now, we are still waiting. Maybe
Yeah.
someone who is writing something in the chat. If no one writes anything, we can finish earlier, but we can still wait.
There is one question.
There is one question.
Yeah, I was
In
just
the chat.
checking the chat, and I see now that Dermot Lynott asks, how do you encourage people to try new approaches like this? Well, that's one of the main challenges, but I think that there are at least two ways. One of them is having like the proper training for this, or activities to explain and to disseminate this approach. And the other one, and more important, I think, is to have the proper technology, as I say in the presentation, to have the technology that implements the affordances to making this as easy as possible. Let's say to make it easier to make it this way than to make it like the old-fashioned way, so to say.
That's great. Thank you, Daniel.
Thank you, Dermot.
Okay, I think in this case we can finish. Thank you very much, and thank you to all the speakers and all the questions. Have a great day.
Thank you.
Thank you, everyone. Bye.
Good day.